Okay. All right, so this is a little bit about considerations for working with Tephra. And I introduced this to a bit ago but again, you have the StravaSpot Tephra help guide that you can get to, and that explains a lot of this on getting data in. Just to show you a couple of things on what we are doing here, the StravaSpot versions both support the full Tephra vocabulary. StravaSpot 1 has Android and iOS capabilities and has the strat mode built in for creating sections. You can only view these and the data on Strabo 2, although you can enter new data onto existing stratigraphic sections if you want, so you can interact that way. This was just going back for the demo of adding a sample to a project. We have these things called quick menus where you can basically give it a specific name, for example, Tephra 1 here, and a label, document some things about the sample. And then once you've saved it, you can click in the sample here and you can get a very detailed list of attributes. Again, these are supporting the best practices. So for example, clicking active eruption would then get you to the next, entry. Is this not advancing? Okay, yeah, there's the next. And again, all these things are following the community established best practices that are that you've gotten a link to before. We can add data, for example, for volcaniclastic rocks, again, for classifying those. You can do componentry, again, supporting the best practices work. So this export to CSV file you see here is a feature in Strabo 1 that will be soon added to Strabo 2. And what this does is it'll allow you to export a CSV file using the AVO, or Alaska Volcano Observatory data format. And then when you come into that, just a second, you'll get a sample ID. You can get various information about the sample, and including specific units by like station, possible source volcanoes, and et cetera. Okay, I want to spend just a few minutes now talking about some aspects of interoperability. And next week, we're going to be hearing about the CSAR and EarthChem systems. And one thing I'll point out is when you collect a sample, or you collect a data point, or you collect any information that you add to a spot, you get a geographic location that you see at the upper right here, but you also get an ID. And that ID should be unique. It's based on Unix time, which is a common thing to use. The first day was January 1, 1970. So this is time in milliseconds since January 1, 1970 with a random digit added. So as long as you're not collecting more than 10 or a few samples per millisecond, you should be okay on using this. It should be unique. So we generate this tag, milliseconds plus random digit. And once you have that, that's unique in StraboSpot. The reason that we put that unique ID in there is that in the database, all spots are stored as separate unique IDs. This gets back to the graph database idea we talked about with these nodes that are data with spots, and then you can link those together. One of the plans we have moving forward is being able to interact seamlessly with the IGSN system, and you'll hear more about that next week. These are more limited in scope as far as what you would give an IGSN to. For StraboSpot, everything has to have a unique ID, every photograph, every piece of data gets one of these IDs. But for samples and interoperability and linking together, we're hoping that we can work something between using the Strabo spot ID, for example, this long number, and getting an IGSN that then can be linked to a lot of other samples and linked to your own personal sample collections. As I noted before, we have put in the stratigraphic mode. It'll be working in Strabo 2 soon. This is a paper we had in Geosphere about that. But again, you could go to an outcrop. You saw this picture before, take a sample. You can collect all the data that you want in context here, and then that context can follow the sample through every analysis and everything you're doing. This is just an example of a stratigraphic column for another area. This is for a place in Utah, but you can see you can add units here. All the units are spots, and then you can ornament this behind with images or add sample spots on this if you want. One question we had come up also is working offline. And Strabo Spot was designed from the start to work offline, that you needed to be able to go out in the field, collect data, as Nick showed early on, collect your data, export it, back it up while you're in the field, but not necessarily have any internet connection whatsoever. You can do that as much as you want with the Strabo mobile app. Once you're back in internet contact, you can upload at that point. But we had requests for, well, we want to put a Strabo system together and use it remotely with all the capabilities. For example, adding images, adding custom base maps. And the specific use case for this was the idea that you're working in an area, you're flying local drone imagery that you can process and georeference, but you don't have any way of getting it to the cloud to bring it back down. This way you could do all of that and upload it using the standalone Strabo Spot server. This is on the main web page, and under software, you're able to get to this. And you can just download a Docker instance of the entire data system and put that and run it locally. So if you wanted to run your Strabo data locally, you could do that. And then all you have to do is create some kind of endpoint that you can reach, a URL, and then you can put that in here and save that for using into the future. So for years, when we were using Strabo Spot to teach field camp at the University of Kansas field camp, we would actually run this local server for the students because we had no internet connection at that time. And we could back up everything and people could see their data. I could see student data, for example. And again, just to kind of emphasize this, the user who uploads data is able to control whether other people can see the data or not. They can make it public or private. They can toggle it here, or you can toggle it within the app so that it can be public or private when you upload it. So if you're collecting data and you want to store it in here, but you don't want anybody else to see it, that's perfectly permissible. And again, I demoed this before with the search capability, and I'm not going to go through that again. And that should be it. Okay. So I just wanted to go through that and emphasize that we're trying to build this interoperability with any sources that we can. Anybody who wants to consume our web services can do that. You can interact from programmatically with the Strabo Spot server. Likewise, we would like to be able to gather data in as it becomes usable. At this point, the main interoperability we have that is pretty seamless is working with Rick Allmendinger's structural geology programs like StereoNet, Faultkin, Geologic Map Data Engine. All of his software applications support Strabo uploading and downloading from Strabo as well. So that's basically what I wanted to go through, just emphasizing this idea of unique sample IDs and being able to collect spots. And we hope in the near future be able to interact with things like EarthChem and CSAR using IGSNs.
Yeah. So these are great developments coming along, and they're going to be huge work savers, because right now getting like IGSNs registered requires some additional steps. But you can imagine, the more we make these, the data digital first, and the more we have connections between these systems, the more efficient we can make people's research workflows and save a lot of time and a lot of effort.
For the IGSN registration, basically you need metadata to go along with it, like location, who owns the sample, and sometime about when it was collected and where it is. All of that sits within Strabo Spot. If you're logged into Strabo Spot, all that information is available. And if you collect a sample, the location and time are available. So it should automate greatly, just being able to do a one-click step of obtaining an IGSN, or at least it could.
Yeah, another comment, because since we do have an international audience here, currently the back end is hosted on resources supported by the U.S. National Science Foundation. But other nations might decide that maybe their national geological agency wants their own system. Could you comment on that?
Yeah, they could download the standalone server and run that themselves, and have a self-contained system. Strabo Spot would like to be acknowledged for that. And then in the future, as those systems get put up, we would like them to be interoperable as well, so that using the web services, people could come in and search those databases. The web services, if you're coming in from another platform, you can send queries to the database and get results back. You could query Strabo Spot live. It would be nice if you were running, say, a server in Belgium that was a local one for some purpose, that then we would be able to send a request to you when people were doing searches, so people could find data on your system. Again, it will support the whole public-private attributes that we've talked about already.
I have a question about the CSV download that you spoke of earlier. And I know you did a wonderful job working with the Alaska Volcano Observatory to specifically format a spreadsheet or CSV download that works for seamless integration into our database. But I wonder about a customizable download, so that you can sort of pick and choose. I want these I collected a ton of data, but I just want a spreadsheet that tells me these 15 pieces of data, and that's it. Is that something that Strabo Spot could do?
Jason, do you want to comment on that?
Yeah, so we have been in discussions as a group about this notion of sort of a template engine, which would allow you to define what data format you want your data to appear in. So for example, you could come in and you could define those 15 columns that you're interested in, and you could both import data in that format as well as export data in that format. And that format, that template would be saved within your Strabo account, which would allow you to use that format in perpetuity. And it would be, specific to your user account, but that would allow you to better customize the way that the data comes in and out of the system.
Oh, that's excellent. Thanks. Thanks for that. Another question I have is, if you guys have been so easy to work with, and we appreciate that so much, just in terms of integrating the best practice guidelines for Tephra. And I wonder if you're comfortable with people sending comments. There's a lot of really excited people, I think, at this workshop, and I'm seeing it in the chat. And if people have specific comments or requests or ideas, if it's best to send those to you via the email address that we posted, or if there would be a benefit to our group using our Google group, I guess, email to solicit comments and feedback and then feed that to you all in one big package, or is there a format that's most useful?
If you do it that way, then other people can see each other's comments, I assume, and then they could build off of that, maybe get some other ideas. So that sounds like a better way for the users to interact with it.
Okay, all right.
They could
Yeah,
send it to that
we can
email
distill
address.
some of the chat and then maybe
That's
send
fine.
a separate question. Okay,
Yeah,
all right. We'll work on that after this workshop.
yeah. Like I say, Strabo has been user driven since the beginning, and you know, the response to vocabulary changes in that, the workflow, Nick working on redesign, and you know, for example, we were originally in 2014 assumed that we would have to have this running on a phone, but we have thousands of users at this point and almost nobody uses phones. So that's why that drove our redesign using tablet size for the Strabo 2. It also, something like 90% of the users right now are using iOS. So even though they could in Strabo 1 use Android. So that's why we focused our initial development on that. The Strabo 2 should be coming out in an Android version, hopefully in a few weeks or a couple months. And I know that having it in Android will also help the international community more. That's largely why we're doing is to make sure that we can appeal to a larger user base.
Yeah, that's great. Yeah, thanks for that. Then there's kind of an obvious question that I don't think I heard addressed today, but maybe I missed it, which is just sort of the long-term life cycle of this funding for Strabo Spot and what you think, you know, what those projections look like, so that, you know, we get a sense of how long this might be in place or hopefully forever.
Yeah, that's a really, that's a wonderful question. And at this point, we've been funded by both Geoinformatics and EarthCube. The initial funding was with NSF Geoinformatics, and we've since been working with EarthCube. When those grants wind down, we will be looking for additional funding and support. We have several proposals in now to continue this. Part of the move to the NSF network was to get that set of interoperability and longevity built into this and get that support built in as well. Right now in the research community, figuring out sustainability has been kind of the prime topic for the last couple of years. And we're still all working on that, trying to figure that out. We've built the system completely open source at this point so that people can come in and interact with it, could make additions or work with it. And we've continued that sort of philosophy in all this. But the long-term sustainability beyond a few years is always, I think, with any data system, is a question at this point. This kind of as a plug, I was president of GSA, Geological Society of America, last year, and I presented the idea that societies like GSA, AGU, somebody else like that, since they've been involved in publishing for 100 years, could they be involved in this in creating data standards and moving on with that? And I think if we could get a society involved, some group like that, we could build this longer term sustainability. The main cost is in starting up and building the capability, and then after a while it becomes mostly just storage cost after that.
Excellent. Thanks for that, Doug. Sounds good.
This has been really great. Thanks, everyone. We've had a tremendous number of questions and ideas and a lot of really useful conversation, and definitely a number of things that we'll be thinking about and sort of some of our next steps. I think of some really great ideas have come out of that will extend this and further and help meet the needs of the community.
Yeah, thank you.
Yeah, thanks so much. We really appreciate it. So Steve, the questions, maybe just go over that again, the Q&A and the videos.
Right. So we will be just like with the first session, we will be posting the Q&A, some things from the chat, and the videos online probably this coming week in advance of the third session. And you'll be able to find that information on the Tephra Fusion website. And we'll also mention it on the listserv just to make sure everybody sees that and knows when it's available and can access it.
And Steve, it's correct that you don't have to have registered for the workshop to visit the website, watch videos, look at all of the links. That's all perfect.
Correct. Correct. The website is accessible to anyone. And so anyone can access that. Of course, the group listserv is just for people who have registered for the meeting, but others are welcome to join that.
So please share the website, share the resources.
Again, thank you everyone for tuning in and listening to our presenters and contributing questions. And thank you to our StraboSpot team for this overview, an introduction to a really, really powerful tool. I think a lot of people have said this is great. I know we've had users before this who've tried it out and said, you know what, I'm not going back to paper notebooks ever again. So thank you very much.
Yeah, thank you. Take care.
Thanks.
Bye.